Looking at some u substitution problems, 7, 123. Let's go through a couple of these. The integral of cosine x of sine x squared dx. So all the way inside has got to be that sine x. So if u is sine x, du is cosine x, which is convenient, dx. So this is all du, and then this is u, so we've got the integral of u squared du, the integral of u squared, u cubed over 3 plus c. Put in the sign. Sine cubed x over 3, oh, that's a cube, plus c. Let's look at b. Negative cosine 3x minus 2. Got a nice clean u here. All the way inside is 3x minus 2, so du is 3. So in this one, I would need to put a 3 here and a 1/3 here in order to have my du be equal to 3 dx. So I put my 1/3 in front. And so I've got, and I'm actually going to throw that negative in front as well right there. So I've got negative 1/3 cosine u du. Integral of cosine u would just be sine u plus c. Put u back in. Negative 1/3 sine of 3x minus 2 plus c. Now let's look at c. The integral of x to the negative 4 e to the x to the negative 3 dx. So all the way inside is got to be there, and so if u equals x to the negative 3 and we derive that, that's going to be negative 3x to the negative 4. So I need a negative 1/3 here because I need a negative 3 there. So negative 1/3, the integral of e to the u du, e to the u, e to the u. So negative 1/3 e to the u plus c, negative 1/3 e to the x to the negative 3 plus c. Keep going. Integral of e to the 7x minus 2 minus 5x. I like this one. So you've got two things going on here. We can't u across, so really we've got basically two problems going on here. We've got the integral of e to the 7x minus 2 minus the integral of the square root of 5 times the square root of x. Once I write it like this, I feel like this one makes a lot more sense to you. We can break that up as the square root of 5 times the square root of x. The square root of 5 is just a number. But let's start over here. We're going to need a u here. All the way inside is the 7x minus 2. So du is 7, so I need a 1/7. 1/7 e to the u, which is going to be e to the u. I'm just going to go ahead and write it. E to the 7x minus 2. No problem there. This guy here, no u substitution required, but I would maybe encourage you to remember that that number can just go in front, and actually calling this x to the 1/2 dx would be smart as well. Integrate that, x to the 3/2 divided by 3/2 times negative root 5 plus c. We could probably clean all that up by multiplying by the reciprocal. Negative 2 root 5 times x to the 3/2 over that 3 right there plus c. That's a pretty solid review problem. This side just your power rule, this side a really small u, but combined it can make it look a little daunting. Cool, keep going. Integral of 2 natural log 4x dx. All the way inside is our 4x. U equals 4x. du equals 4. So that means I'm going to need, this is a 2, I want it to be a 4, so I need a 1/2 there, because that'll be a 4 then. So 1/2 natural log, nope, caught myself. This is a 4, so I should put a 1/4 here. But I'll actually multiply it by the 2 and make it a 1/2. That's where I was going with that. Of the natural log of u du. Now, this is not one that I necessarily have memorized from the back of the book. The antiderivative of natural log of u du is u natural log u minus u plus c. We've still got a 1/2 in front of the whole thing. Put our u back in, 1/2 4x times the natural log of 4x minus 4x plus c would be just fine to finish that. You could multiply the 1/2 through and call it 2x and 2x. That'd be just fine. And f, the integral of 9 over 9 plus x dx. U is 9 plus x. Du is 1. So we really have 1 over, we have 9, I guess. I'm going to put that 9 here. 9 times 1 still gives me that 9 over u du. There's our special one. The integral of 1 over u is the natural log of u plus c. So 9 natural log 9 plus x plus c. Good problem, lots of u's. I really like how in this one we derived 1 over u. This one we derived natural log of u to remind ourselves that other than the integral of this is this, the integral of that, of course, is not this. The derivative of that would be this.